Here we have the Level 3 notes for Biddeford High School Graduation Standard A1.1 Solving Equations. So, during the standard, our learning target, you will be able to solve equations in one variable using multiple steps. Okay, so think back to Level 1. That's where we were able to solve one variable equations using one step: addition, subtraction, multiplication, and division. In Level 2, you were able to solve one variable equations except using two steps. The only difference here, we have multiple steps, so more than two. Okay, so we'll deal with multiple step equations, variables on both sides. So at this point we've seen a variable on the left side or the right side. During the standard we'll have variables on both sides. You'll also be able to solve a proportion. Are you supposed to know what a proportion is at this point? No, well, you've probably heard of it before. But proportions actually have their own standard that we will go over later. It is actually A1.3, which is after A1.2, which is inequalities. Okay, so let me get my pen here. We can get started. So, is there much of a difference between this level of the standard and the previous two? As we just said, no. We are still trying to isolate. Remember, isolate means to get by itself our variable. So our end goal is still the same. The only difference is we are solving more complicated equations. Great, awesome. So, there are a few new rules that we need to learn. Some I'm sure you might have seen before, but if you haven't, it's completely okay. We'll learn it right now. So, let's look at a problem. And right off the bat, we start off with parentheses here. Okay? So, how do we solve a problem like this? Okay? If you're thinking right off the bat, well, we have a plus 3. We could probably subtract 3 on this side and subtract 3 on that side. It's not quite that simple. Okay? So whenever we have parentheses, we use something called the distributive property. Okay? So I'll wait a second for you to write that down. Okay, so what does the distributive property tell us? So, the distributive property tells us that whenever we have an expression in parentheses multiplied by a variable or number, we can get rid of the parentheses by multiplying the number or variable, depending on the situation, outside the parentheses. By all terms inside the parentheses. So let's look at a general situation. So the example I'm about to give you uses letters, and it applies to any situation where we have to use the distributive property. So in simplest terms, let's say we have A, and in parentheses we have B plus C. Okay, trying to figure out what that equals. Okay, so let me change my color here. So let's go back up here. Multiplying the number or variable outside the parentheses. So my variable or number outside the parentheses in this general situation is A. We all see that? And we're multiplying it by all terms inside the parentheses. So my terms inside the parentheses are B and C. So what I like to do, I'm going to draw these little lines connecting A to B and A to C. So now I just multiply them. So I have A times B, which remember I can just write as AB, plus A times C, which again I can just write as AC. Awesome. Okay, so let's look at that original equation that we had up towards the top there. Brought it right down here. Find the easiest way to learn how to do these is to put them to use. So I have 5 times the expression 2x plus 3 equals 85. So I'm going to take this 5, I'm going to draw my little lines here. So I have 5 times 2x. So what's 5 times 2x? That would be 10x. Plus 5 times 3. And what's 5 times 3? That's 15. And of course I'm going to bring down this plus sign right here. That does not change in this example. And then of course I have my equals 85. So just like in level 2, what we wanted to do was we wanted to get the expression that had the variable by itself. That way we would have a one-step equation with one variable, which is level 1. So we were just trying to break it down as much as we could so we could get to a level 1 problem and solve a level 1 problem. That's what we did in level 2. Now that we're in level 3, we have level 3 problems, multiple steps. We're trying to break it down to a level 2 problem, such as this. So now we're going to break this down to a level 1 problem. Then we'll be able to solve using one step. Great. So, going back down here, if I did not have this plus 15 here, if I had 10x equals 85, I would know how to solve that. But since I have this 15 here, I have to get rid of it. So it's being added, So I'm going to subtract 15 on both sides. Draw my little T-chart here. Okay? Just because I'm running out of space, I'll head up here. So, I have plus 15 minus 15. So what's 15 minus 15? Cancels right out. I get 0. So what am I left with on this side? Just 10x. Now I'm going to go over to this side. I have 85 minus 15. So, in our head we could do it using a calculator. However, 85 minus 15 is 70. So I went from a 3-step problem over here, or multi-step problem over here, to a 2-step problem down here, over to a 1-step problem. So we know how to solve these. I'm going to make my t again. I'm going to divide by 10 on both sides to get x by itself. So this 10 will cancel. So I have x equals 70 divided by 10. So what's my final answer? X equals 7. Perfect. I'll give you a second to write that down. Alright, moving on. So another situation that we will be faced with is when we have two fractions that are set equal to each other. In this case, with variables, because we're trying to solve for variables. Okay? These are called proportions. Again, which I'm sure you've heard of before in some capacity. If you don't remember what they are, how we use them, that's okay. We'll learn that right now. And even more in standard A1.3. So let's look at a problem. So right here I have two fractions that are set equal to each other with one variable. So 8 over 6 equals 4 over some value. Okay? So how do we solve these? So to get that x by itself, we have a special property that we use. And it's called cross multiplying. Okay? So, what do I mean by cross multiplying? I'm going to go to this 8 up here, draw a line down to my x. I'll go up to my 4 up here, and draw a line down to my 6. Okay? So I've made my x. So, I have 8 times x. I'll write this up here. 8 times x equals 4 times 6. So to simplify this, I have 8x equals 24. Okay? I'll just write this again up here. So 8x equals 24. So I'm going to make my t-chart and divide by 8 on both sides to get x by itself. So my 8's will cancel, and I'm left with x on this side equals 24 divided by 8. So in your head, using a calculator, any other strategy you might have, 24 divided by 8 is 3. So x equals 3. So that's how we solve proportions generally. Again, in this situation right here, you probably could have used the guess and check method. See, we have an 8 up here, and we have a 4 over here. Well, you could look at it and say, well, gee, 4 is half of 8. So if I go down here, x must be half of 6. So from that, you could probably guess that x equals 3. But when we get into more complicated proportion problems, you'll want to use this cross-multiplying strategy. Okay? So, just to reiterate what I just said, proportions tell us that these two fractions are equal, and we can solve for proportions by cross multiplying. Great. And there's our example again. We did it up here. So let's take a look at another example. So here we have 4 divided by the term x plus 5 equals 2 over 4. So how are we going to solve this? We're going to cross multiply. So I'm going to draw lines just so I don't get confused. So I'll be multiplying the 4 by 4 and the 2 by x plus 5. So I'll write that all over here. 4 times 4 equals 2, and I'm multiplying by the term x plus 5. So I need to put it in parentheses. So this reads 2 times x plus 5, which is exactly what I want to do up here. Great, so now I'm just going to simplify. So what's 4 times 4? 16 equals, good thing we just learned how to do this. We are going to use the distributive property to simplify this. So I'll draw my lines. 2 times x and 2 times 5. So 2 times x is 2x plus 2 times 5, which is 10. So there, we had a proportion problem, multiple steps, and we broke it down to a level 2 problem. 2 steps. We know how to solve this, so let's just go through the process. I'll make my t. Okay. So my first step, I need to subtract 10 from the expression that has my variable. So whatever I do on one side, I have to do to the other. My 10s will cancel out. I'm left with 2x on this side and 16 minus 10, which is 6. So let me just rewrite that. 6 equals 2x. Awesome. I'll make another t. So divide by 2 on this side to get the x by itself. Divide by 2 on the other side. So our 2's will cancel. So I'm left with x equals 6 divided by 2, which is 3. And keep in mind, if we were unsure of this answer, we could take this 3 and plug it right back into our original equation. Great. So let's scroll down and do a couple practice problems. We'll do these two first. Alright, so solve each equation, and answers may be left as fractions. Again, in Algebra 1, it's okay to leave solutions as fractions, especially improper fractions. We don't need to find mixed numbers or decimals of any kind. Because as it turns out, improper fractions are a lot easier to graph, which we will deal with in standards A2.1 and A2.2. Okay, so I have the same goal in mind as always. I'm just going to try to isolate my variable. So notice I have 2 minus 7p on this side, and I have p minus 6 on this side. So I have a p on this side of the equation and a p on that side of the equation. So my goal right now is to get the p's all on one side. So having said that, I'm going to add 7p. Again, there's a couple different ways to do this. And add 7p over here. So negative 7p plus 7p, going to cancel. So I'm left with 2 on this side, my equal sign. What's p plus 7p? Keeping in mind that when it appears that we don't have any coefficient, the coefficient is actually 1. So we have 1p plus 7p, which is 8p. And then our minus 6 tags along. So again, we have a two-step equation here. Almost there. Draw my chart. So now I'm going to add 6 on this side and add 6 on this side. 6's cancel over here. I'm left with 8p equals 8. So to get the p by itself, one more t-chart. I'll divide by 8 on both sides. So 8's cancel here. So p equals 8 divided by 8, which we know is 1. Awesome. Alright, let's move over to this one. Same thing. Okay, I'll start by trying to get all my variables on one side. So I'll go over here this time. I'll add 7m on this side. I'll add 7m on the other side. So negative 7m plus 7m cancels out. So I'm left with a 1. Negative 6m plus 7m. It's a positive 1m, which I can just leave as m. So 9 plus m. If you're confused about this at all, you can just bring down the 9 to start off with, and then do the math with the m. So then you have negative 6m plus 7m. So this changes from a negative to a positive, because it's a positive m, negative 6m plus 7m. Okay. T-chart here. I'll subtract 9, get the m by itself. 9's cancel. Left with m on this side equals 1 minus 9, which is negative 8. Easy enough? Great. Well, I'll move on. Okay, let's do these two. So, look at this one right up here. We know we have to use the distributive property. And why is that? It's because we have parentheses and a term being multiplied by that term in parentheses. So, draw my lines here for what I need to multiply. So I have 7 times r, which is 7r. And I have 7 times 5, which is a positive 35, equals 91. So, get that r by itself, isolate it, subtract 35 on this side, subtract 35 on this side. So 35 minus 35 is 0. So I have 7r equals 91 minus 35. 91 minus 35 would be 56 positive. Okay. So one more t-chart. Divide by 7 on both sides. 7's cancel. I have r equals, what's 56 divided by 7? If we're pretty good with our multiplication tables at this point, we know that is 8. Awesome. Okay, now I'll go right over here to the second one. And again, we have another distributive property problem. So, there's a couple things we could do here. We could subtract this 8 over onto this side, or we could just hop right into the distributing, which is what I always like to do. Get rid of the parentheses early. So, draw my lines right here. So, I'll write down my equation over here. I have 108 equals 8. I have negative 5 times 1, which is negative 5. And I have negative 5 times negative 3r, which is a positive 15r. Okay. So I'll go right down here. Let me simplify that. I have 108 equals 8 minus 5, which of course is 3, plus our 15r. So I just combine the 8 and the negative 5. So I'll draw my t-chart. Subtract 3 on this side, subtract 3 on this side. 3 minus 3 cancels. So I have 15r on one side. And 108 minus 3, which of course is 105 on this side. Okay, so now one more t should do it. Divide by 15 to get the r by itself. So 15's cancel. And I have r equals, you might need a calculator for this one, 105 divided by 15, which happens to be 7. Great. On to the next one. Okay. So here we have a proportion problem. If you forget how to do these, go back in your notes, of course. So, what I always do, I'm going to draw my x. Pair up what I'm multiplying. So I have 2 times 2, which is 4, equals r times 7, so 7r. So I'll draw my t. Divide by 7 to get the r by itself. 7's cancel. So I'm left with r on this side. And on this side, 4 divided by 7. So can we simplify that at all? No, not really. So, since our instructions said we could leave answers as a fraction, this is a perfectly okay answer. I'll be happy with that. Again, you can put it into decimal form, but you really don't need to. Okay? So let's go over to this one. Draw my x's and write out my new equation, or set up my new equation. So I have x plus 6, this entire expression, times 2. So I'll write that as 2x plus 6. Then my equal sign, and I have 5 times 6, which of course is 30. So, I'll draw my lines here, so I know I have to distribute, because we have parentheses. So 2 times x, which is 2x, and 2 times 6, which is 12. Of course, we have our equals 30. So, now I have a two-step equation which I know how to solve. So I'll subtract 12 on this side. My 12's cancel. Subtract 12 on this side. So now I'm left with 2x equals 30 minus 12, which we know is 18. Okay, so I have 2x equals 18. Okay, draw my t, should be the last one. Divide by 2 to get x by itself on this side and that side. 2's cancel, so I have x equals 18 divided by 2, which of course we know is 9. Great. Give you a second to write that down. Moving on. 4 more problems here. So, I'll go right up to this one. Again, nothing different here. So I have 4 times v plus 3. So I'll write that. And it's the expression v plus 3. So I'll put it in parentheses. Equals 3 times v, which is 3v. At this point, I'll switch my marker. I know I have to distribute, so I'll draw my lines. Okay. So I have 4 times v, which is 4v, and I have 4 times 3, which is positive 12. Of course, on this side I have 3v. Great. So, let me rearrange this. I need to get all my v's on one side, remember? So I'll subtract 4v on this side and subtract 4v on that side. So 4v minus 4v cancels. I'm left with 12. And I have 3v, positive 3v, minus 4v, which we know is negative v. So some of you might think we're done, but we're not, because we're trying to solve for v, not negative v. So because I have 12 equals negative v, I need to divide both sides by negative 1. and that will get rid of my negative sign up here, because remember, this is the same thing as -1 times v up here. So if we have -1 divided by -1, they'll cancel. Same thing over here. So I have v equals 12 divided by -1, which is just -12. Nice job. Okay. Go over to this one. Now I have a proportion. So I'll line up what I need to multiply. So I have 5 times v minus 9 equals 3 times v plus 5. Uh-oh. Great. So I'm distributing. So I'll draw my lines. So I have 5 times v, which is 5v, minus 45 equals 3v plus 15. So I need to get all my v's on one side. I'll bring them all over to the left side. So I need to subtract 3v over here, subtract 3v over there. 3v's cancel on the right side, so I have 5v minus 3v, which is 2v. And of course I have my minus 45. Equals, and on this side I have just 15. Okay? So I'll make my t-chart. I'll add 45 on this side. And I'll add 45 on this side. So negative 45 plus 45, that cancels. So, because I'm running out of room, I'll go right up here. I'm left with 2v equals 15 plus 45. So 15 plus 45, which is 60. So, one more t-chart. Divide by 2 to get v by itself on both sides. So I'm left with v equals 30. Alright, so let's go down to this bottom one over here. So, as I said, I like to distribute first. So let me draw my lines for what I need to multiply. So, I have negative 7 times negative 4k. So I'll just multiply the coefficients, so I get 28k. And I have negative 7 times negative 1, which, keep in mind, is positive 7, so plus 7. Then on my other side, can't really simplify that yet, so I have 7 plus 8k. So for this one, I'll bring all my k's over to the left side. So I'll make my t-chart, subtract 8k over here, and subtract 8k over here. 8k's cancel on the right side. So over here I have 28k minus 8k. So for that we have 20k. And of course I have this plus 7 that'll just drop down. equals 7. And that 7 comes from right over here. So I have all my k's on one side. So let's isolate it. Subtract 7 over here. Subtract 7 over there. So those cancel. So I have 20k equals 7 minus 7, which is 0. Okay, move right up here real quick. $20k equals 0. So, get the k by itself, one more t-chart. Divide by 20 on this side. Divide by 20 on the other side. So I get k equals 0 divided by 20. So what's 0 divided by 20? 0. So that's our final answer, or our solution. Okay. Alright, let's take a look at this next one. Last one. Almost there. Okay, so on this one I have two distributions that need to be made. So, again, not changing my process at all. I'll draw my lines and write my new equation. So I have negative 6 times x, which is negative 6x. And then I have negative 6 times negative 5, which is positive 30, equals 3 minus, I have negative 3 times 3x. So that's negative 9x. And then I have negative 3 times positive 1, which is negative 3. There, no more parentheses. Now we can solve for x. So, let me combine my 3 and my negative 3 on this side. So, my new equation, or simplified so far, is negative 6x plus 30 equals, well, 3 minus 3 is 0, so I don't need to write 0 in there, so I'll just write my negative 9x. Awesome. So, get my x. My x is all over on one side, so I'll add 6 over here. And add 6x over here. Okay. Negative 6x plus 6x, we know cancels. So we have 30 equals negative 9x plus 6x, which of course is negative 3x. Okay. One more t-chart. Divide by negative 3 to get the x by itself on this side. Of course we do it on this side as well. Negative 3 divided by negative 3 is 1. So we know our x is by itself equals 30 divided by negative 3, which we know is negative 10. There. And with that, our A1.1 solving equations level 3 notes are completed.